Mathematics, how much gold can you hold in an elephant's ear? When it's noon on the moon, then what time is it here? If you could count for a year, would you get to infinity or somewhere in that vicinity? When you choose how much postage to use, when you know what's the chance it will snow, when you bet and you end up in debt. Oh, try as you may, you just can't get away from mathematics.
Good morning and welcome to the first edition of Online Learning with Mr. Wiebe. Welcome to my grade 11 physics class. This is exciting to be doing it this way for the next little while, different, as I'm speaking to an empty classroom, but I think we'll have a lot of fun doing this, and hopefully a little bit of learning will happen as well, and I hope to see you back in the classroom as soon as possible. We are starting a new unit today on electric fields and electric forces, and today we're gonna get into it slowly. We're gonna just do a really light lesson today on many things that you already know, but may or may not remember. We just want to make sure that we start off on the right foot with the same general knowledge, and then tomorrow and to the next couple of days we'll get into more of the meat of the unit that we're getting into now. So first thing, a couple of things. We're looking at electric charges. Now the first thing you have to remember is that electric charges are invisible, we can't see them, and they work almost identically to magnetic charges, which you have all experienced and seen. You have all at some point in your lives played with magnets and realized some of the magnetic properties that magnets have. Electric properties, electric fields, and electric forces work the same way. Some background knowledge. First little thing, electric charges were first discovered by the early Greeks when they were studying things, and as some Greek mathematicians rubbed some amber stone on various things, they realized that that amber stone would attract bits of straw, bits of clothing, those kind of things, and the Greek word for amber is electron. And so from that came our basis of electricity, and what the Greeks did was then when they rubbed other objects and they began to attract or exhibit similar properties to the amber stone, they would call that the amber effect, and all of that combined into our knowledge today of what electricity is. Now of course they didn't have the technology to look inside of atoms and realize some of what was actually going on, but they developed some of the very clear properties that we already know, and we can see some of them on the board behind me. We know that opposite charges attract one another. We know that similar charges repel one another. And we also, maybe not quite as clearly, but we do know that charged objects will always attract neutral objects. So those are some of the things that they understood early on. As we developed more and more technology, we learned more and more about why these things were happening. And so we're just going to go through a few quick points on the structure of matter and how things become charged. And then I've got a reading out of your textbook and a few questions, and that'll bring to the end of today's lesson. So, first things that we have to know, some principles about matter. You all know, I'm sure that you all know that matter is composed of subatomic particles called atoms, and that every particle, everything that we have around us is made up of atoms. Within atoms, there are charged particles called electrons and protons. And again, we all have a fairly good understanding of that. Protons are in the central region, in the nucleus of an atom. They are fairly heavy in relation to other subatomic particles, and they have a positively charged, and they're positively charged. Electrons, of course, are surrounding the nucleus in the free space around them, and they have an electric charge. They are fairly small and fairly light compared to protons, yet they have the same charge as a proton does, just negative rather than positive. Atoms are normally electrically neutral, meaning they have no charge because the number of protons and the number of electrons are equal. There's also neutrons that are in the nucleus as well, along with the protons, and they are there. They add mass to the atom, but they are electrically neutral. They have no charge on them. So how does a particle become charged? Well, those electrons that are in free space surrounding the nucleus can be removed, or they can be added to atoms. And when we remove electrons from an atom, then that atom becomes positively charged, known as a positive ion. And conversely, when electrons are added to an atom, then it develops a negative charge and becomes a negative ion. One important thing to remember is that all electric charges, all of them, result from either an excess or deficit of electrons. That is the only way that particles get a charge, is either by removing or adding electrons. The protons and the neutrons are fixed in the nucleus and are not free to move around, but it's the electrons that can move from one atom to another atom, creating positive or negative charges. All right, that is the basis of what we're going to be talking about for the next little while. And so that's all I wanted to share with you today. Fairly straightforward and fairly simple, and again, some things you know. Now, I do want you to do some reading out of your textbook. In your textbook, chapter 20 starts dealing with this concept of electric fields and electric forces. And so there's a section in your textbook, section 20.1, that I would like you to read. It talks about charged objects. It talks about how to charge objects. It asks you to do a few little mini experiments that you may or may not have done in your past, but if you've got little siblings around that you want to entertain, might be fun to do some of them that they suggest, but you don't have to, not required to do them. And at the end of the section, there on page 545 of your textbook, there are 7 questions that I would like you to do, questions 1 through 7, and I would like to get those done. And that's it. That's it for today. Fairly straightforward, fairly simple. Read a few pages of your textbook. Do the few questions that will give us a bit of a basic understanding. And as we move forward in this unit, we're going to be looking at the force that these charged particles create. Obviously, if charged particles attract or repel one another, there must be some kind of force that is doing that, and that's what we want to look into as we move forward in this unit. And of course, there will be some math and some formulas involved, and that's when it starts getting really fun for us. So do what you have to do. As we go from here today, I get a daily verse sent to me regularly, and so I want to share with you a daily verse as we leave today. And so today's was actually the verse that was shared in my church's sermon yesterday. So it is from Philippians chapter 4, and I'm going to read verses 4 through 9, and you can reflect on this as you go throughout the rest of your day as well. It says, "Rejoice in the Lord always. I say it again, rejoice. Let your gentleness be evident to all. The Lord is near. Do not be anxious about anything, but in everything, by prayer and petition, with thanksgiving, present your requests to God, and the peace of God, which transcends all understanding, will guard your hearts and minds in Christ Jesus. Finally, brothers, whatever is true, whatever is noble, whatever is right, whatever is pure, whatever is lovely, whatever is admirable, if anything is excellent or praiseworthy, think about such things. Whatever you have learned or received or heard from me or seen in me, put into practice, and the God of peace will be with you." So, peace be with you as you go throughout the rest of your day. Enjoy your day. Do a little bit of reading out of your textbook, and we'll see you tomorrow. Have a good day.